Welcome to Physical Science. This lesson is on static electricity. We will start our class off with a check-in question, so you can go ahead and take a look at that before class begins. Our objectives are stated here, and these are the ones that we've been covering throughout this unit. Our goals for today are to understand what is static electricity. So one of the review questions that we will go over in class will be, how are magnets and electric charges similar? How are they different? And so you're going to be asked to write your responses up on the board. So just to kind of review that a little bit, if you weren't clear, or it was something that we didn't have a chance to go over in our last lesson, remember that a magnetic charge cannot exist by itself, okay? It has, whether it's a bar magnet or it's a horseshoe magnet, it has a magnetic field that surrounds the entire magnet. It always has a north pole and it has a south pole, okay? So it just can't exist by itself. It always has a north and a south pole, and the magnetic field starts from the north and surrounds the magnet and then comes back to the south. An electric charge can exist on its own. A negative charge can exist on its own, and a positive charge can exist on its own. And we discovered that in that little activity that we did in class. An electric field does surround the charge itself. So some things that they have in common is that they both do repel and attract. So positive charges attract negative charges. Negative and negative repel, positive and positive repel. Just like north and north repel, south and south repel, and north and south attract. It is considered a force, so there is a magnetic force and electrical force, and there is that magnetic and electric field. So the question will be, when we come to class, is how is an electric charge produced? So that'll be a question that you'll need to answer in class after you watched this lesson. So when we talk about electric charges, there are two types. There's static electricity, and then there's current electricity, okay? And this lesson is dealing specifically with static electricity. Static electricity usually comes in the form of friction. It's a transfer of electrons, and there is this electrostatic induction. Current electricity, which will be covered in a different lesson, is the electric potential, and that's where there are 2 points, and those 2 points are connected through a conductor. One point will have more electrons than the second point, okay? And there's a positive terminal and a negative terminal, and that creates electric pressure, which we call voltage. So static electricity, what is it? Okay, static electricity is the buildup of electrons. And what'll happen is that those electrons will build up on an object. The electrons don't flow, they stay static, they stay in place, they don't flow continuously. And what'll happen is that between two objects, those negative electrons will be transferred. Now, one way that static electricity is created is through friction, okay? And lightning is an example of, an extreme example of static electricity. So when we have this buildup of static electricity, it's through friction, okay? When two objects rub together, okay? And then that static electricity can be can be transferred through conduction or induction. So when we talk about these three components of static electricity, friction, remember, is when two objects rub together. So like if I rub my hands together, I can produce heat, okay? And that's friction between my hands. One object will gain electrons, which are negative, and the other one will lose electrons, which will make it positive. Okay, just like when we talked in chemistry about how some elements will gain electrons and others will lose it. So if an object gains electrons, it has more electrons than protons, so it's negative. And when an object loses electrons, it has more protons than electrons, so it becomes positive. Static electricity is then discharged two ways. One way is through conduction, and conduction is when there's contact between two objects. So you have a charged object that'll touch another object. Those electrons are then transferred between the objects, and it's usually like a shock that you get. And the transfer happens from the object with more negative electrons, with more electrons, to the more positive object. And conduction is direct contact. Induction is also a transfer of electrons, but the objects don't touch. What will happen is that the electric field around the object will either repel the electrons or attract the electrons. So it's kind of like when you're reaching for the door handle to turn it, and all of a sudden you get zapped. You kind of feel that little shock. That's induction. That's a transfer of that static electricity between your hand and the door handle. But you haven't touched it yet, but that transfer has happened. So the question that I'll ask in class, and that you should think about as you're watching this recording, is do all of the atoms in the substance give up electrons when another object rubs against it? So during that process of friction, do all of the atoms in that particular substance give up its electrons when another object rubs against it? So when we talk about static electricity, there's this static discharge. And one of the most dramatic examples of this discharge, sometimes you see it like as like a little spark, but the most dramatic spark is lightning. And lightning is a static electric discharge. And so in a thundercloud, there are positive and negative charges, and it's due to the movement of those air molecules, water and ice particles in the cloud, and they're all rubbing together. So what'll happen is that there are positive and negative charges that'll occur. The positive and negative, what'll happen is that the negative charges repel electrons on the ground, so the ground below the clouds will become positively charged. So the atmosphere doesn't allow those electrons from just like flowing away. And as those charges build up, the air between the area also becomes charged, and the static electricity is discharged as bolts of lightning. So it's kind of cool. So another question I want you to think about are what kind of examples are there of static electricity other than the ones that I've given you so far? What are some other examples of static electricity? What we'll be doing in class will be a breakout room activity, and we'll be using a simulation called John Travoltage, where we will be studying a little bit more in depth on static electricity. So make sure that you are ready to go and you've watched this recording and you're ready to go with the answers to my questions. So I am looking forward to this activity in class.